So, in this class we will try to find out more quantization. So far we have considered 3 quantization and corresponding quantum number we have got. So, this basically principal quantum number n, okay. It can take value 1, 2, 3 etc. And then we have got azimuthal quantum number k that can take value 1, 2 up to n. So, it can take n number of k value, and then space quantization, magnetic quantum number mk, it's minus k to 0 plus k, okay. So, that is what we have seen, and we are able to explain normal Zeeman effect, but we are not able to explain this other fine structure of spectral lines. So far we have got for H alpha line, it is split into 3 lines as per the quantization, but experimentally it is found that 5 lines, right. And for sodium D lines, it has more lines D1, D2. Anomalous Zeeman effect, it is telling that it is not split into not 3 lines, but it is more than 3 lines. So, what are the source of these more lines? It is definitely there will be more splitting of the energy levels. So, more quantization we require, and so that is the motivation for searching new quantum number. And before that, you see, actually in 1925 Uhlenberg and Gaudsmith, Uhlenbeck and Gaudsmith, not Berg, Uhlenbeck and Gaudsmith, okay. So, these 2 scientists, they propose another angular momentum, that is the spinning. They consider the spinning motion of the electrons apart from the orbital motion as it is seen in case of solar system. In case of solar system, that planet, it rotate in a orbit, right, elliptical orbit. So, orbital motion, it has angular momentum. Now, it has also spinning motion. So, it's rotate about its own axis, okay. It is going as well as it's rotating about its own axis. So, that is called the spinning motion. So, it is there for solar system. So, in this case also they consider the similar spinning motion of the electron. When electrons are rotating in a orbit, it also has spinning motion, it rotates about its own axis. So, spinning motion, they consider spinning motion of the electron spinning motion of electrons in orbit. So, spinning motion of the planet, that is that was, I think it was well known, because why we see day and night. So, that is because of spinning motion, okay. Spinning motion of the earth, and we are in earth. So, due to the spinning motion of the planet Earth we see day and night, okay. Within 24 hours we see half portion is day and half portion is night, because wherever we are, so we are going just after, so due to spinning motion we are going to just opposite to the sun. So, sun rays cannot reach, but other part of the earth the people are there. So, when we have night they have day, okay, like USA, America and this India. When in India when it is day, in America it is night, okay, because they are in opposite on the earth, okay. So, this is due to the spinning motion, and season change, it is winter, it is summer, this is because of the motion in orbit, okay. It is coming close to the sun, the summer, it is going away from the sun, this it is winter, okay. So, it is realistic consideration that the electron also should have spinning motion. So, it has spin angular momentum, S spin angular momentum, okay, so this one can write PS, spin angular momentum PS, like it is similar to orbital angular momentum Pk, okay. Now, what I will do, just I will change the notation once more. So, this K, so earlier this, you remember this n theta that I replaced by K, okay. So, this I was doing because of the historical development. So, that is change with historical development, and ultimately it is going now in modern time we use this for to present the angular momentum, we use L, okay. So, now I will change this K to L, okay, K to L. So, this angular momentum I will consider now, I will write L not K, okay, but same thing. There is only difference that K value whatever we have taken 1, 2, 2, 1, 2, 3 up to n, but and K equal to 0 was not allowed. So, total number of K value is n number, okay. So, L value will take, so I will K replace, but L value will take starting from 0, 1, 2 up to n minus 1, okay, up to n minus 1, 0, 1, 2. So, total number of L value is n, okay, total number of K value is n. So, that is there, but only this value 1 instead of 1 to n, it is 0 to n minus 1, okay. So, that we will consider, and what is the origin of that one? That basically it comes from quantum mechanics, okay. So, that we will see later on. So, now I will use this modern, our recent notation. So, now I will write PL. So, PL is basically angular momentum, orbital angular momentum, okay, the spin angular momentum, and this is the orbital angular momentum. Okay. So, it is a LK PL, basically this angular orbital angular momentum, it is quantized. So, PL is equal to L h cos instead of K h cos. Now, we are writing L h cos, and then this also again quantized in space. So, that was PL cos phi equal to M K I was writing, now I will write ML, magnetic quantum number ml h cross. Okay. Similarly, this is the it is also angular momentum. So, similar concept here also the space quantization and as well as this in angular momentum quantization. So, that is also applicable here. So, in similarity it is one can it was written that Ps this is basically S H cross L H cross here S H cross, okay, and then Ps cos phi, okay, Ps cos phi. Again this is because cos phi we have taken it's quantized in the same fixed direction in space, okay, whether it is direction of the magnetic field or any fixed direction in the space. So, this similar way Ps cos phi. So, this phi that phi may not be same, it may be different, but concept is same, okay, angle in space. So, this also one can write MAS. So, it is ML, it is MAS H cos, okay. So, L value here we have seen L value it can take 0, 1, 2 is quantized, okay, quantum number. So, up to n minus 1, up to n minus 1. Similarly, S value it can take, S value is basically taken only half spin, electron spin, this S value is only half, okay. For one electron this S value is half, and here ml value what we have seen, this minus L to plus L. Similarly, for ms value is here also it is a half. So, it can take minus half to plus half, okay, minus S to plus S, S is half. So, difference always difference between these two is 1, you know, difference between this one or successive two quantum number, okay, it is 1 always. So, here also it will be 1 if I take minus S2 plus S. So, ms can take value only 2 plus half and minus half, okay. So, I have shown you the meaning of this space quantization. Here meaning of the space quantization is similar way, you know, this is the fixed direction, this is the fixed direction, and spin direction is whatever the spin direction. So, whatever the spin direction, say this is the spin direction, okay, cos phi, S cos phi, Ps cos phi. So, this is the Ps like Pk whatever we have. So, it is space quantization is projection along this, okay, projection along this. So, that is the ms value. So, ms will be only two possible value, one is plus half ms value. So, its direction will be such that it can take only two direction, so that in this direction ms value will be plus half and minus half. So, it can so these two orientation is possible, it is minus half, okay. Now, here Ps itself is half H cross, you know, half H cross, S equal to half, okay. So, this cos phi is basically here. So, projection if I want to get half, so it can be in this direction, it has to be in this direction, or if I want to get minus half, it has to be in this direction, okay. So, okay. So, it has two component S, it has two component, it is the along the space direction fixed in space or magnetic field direction, or opposite to the magnetic field direction. Only these two states are possible for spin, okay, for spin. So, this is the another consideration for quantization, where one new angular momentum is introduced, that is spin angular momentum, and then it is also quantized in same manner as orbital, we have whatever we have seen for orbital angular momentum. Okay. Now, in our system, two quantum number are available, two angular momentum are available. Okay. Now, how these angular momenta are behaving in the system, okay? Whether they can be coupled or they are independent, they do not talk each other. So, that is question arises. So, we have seen this for spin S and this for S, and similar way we have seen for angular momentum, it is right. So, these three is possible for L equal to 1, when L equal to 1. So, this is a L equal to 1 means ML value will be 0 plus 1 minus 1, ML value, here MS value and here ML value. So, this we have seen, and this basically S value is, spin is generally in the same direction, S, this is the S and this is the L. Okay, angular momentum. So, now also we will replace this PL, this whatever angular momentum we wrote. So, this will replace by just L. Okay. Angular momentum is L. Okay. Instead of PL we write L, and instead of PS angular momentum we write this the S. Okay. So, this just we are changing notation, and now coming towards the present notation we are using. So, S whatever I have written here. So, this is the spin angular momentum and its direction is this. These are the orbital angular momentum and their direction. These three directions are possible for L equal to 1 in space, so that its ML value will have these three, 0 plus minus 1. Okay. So, now this existence of spin was discovered experimentally, it was found, but it was found, I think this experiment was done before this, before 1925. The experiment was done in 1922. This very famous experiment, the Stern-Gerlach experiment. Which experiment? The Stern-Gerlach experiment that was done in 1922 by Stern and Gerlach. This Gerlach, GER or GAR, I think GER. Stern-Gerlach experiment, very famous experiment. That experiment confirmed the existence of the spin angular motion, spin angular momentum, or existence of spin of electrons. Okay. So, let me describe this experiment briefly. This is very nice experiment and easy experiment. What was that experiment? I think here itself just simply I can, but in 1922 the experiment was done not to find out the spin angular momentum or existence of spin, it was done to check the space quantization, to check the existence of ML space quantization. Okay. So, in this experiment the silver atom was taken. So, there was a oven, So, here silver metal was taken, and it's heated, it's oven basically, it was heated, and then from here this silver atom as a vapor, silver atom was coming out. So, it was collimated, it was passing through a small hole. So, beam of silver atom was coming, okay. Beam of silver atom was coming, and then here this one screen was put, is basically metal screen. Metal screen was put, and silver will deposit on the screen, because the screen is metal screen is cold. So, this silver beam with kinetic energy, because of the temperature, is kinetic, with kinetic energy it will move and it will reach to the metal screen, and silver atom material will be deposited on this. Okay. Fine, that is no problem. Now, they applied magnetic field, here, but that field was not uniform field, means field, this beam is going, the field is not uniform. Okay. It was inhomogeneous magnetic field, it is not uniform or homogeneous magnetic field. Homogeneous magnetic field means, you see this its intensity of field in any direction at a particular direction, say, okay. Intensity of field is same intensity of field is at everywhere, it is same. So, this then it will be uniform magnetic field or homogeneous magnetic field. Okay. They considered the inhomogeneous magnetic field, inhomogeneous magnetic field B. Okay. Reason is that if you put, and this atom was neutral, silver atom, neutral atom, there, okay, there is no charge, okay, just atom is moving. Okay. So, if I apply magnetic field, so if the atom is not having magnetic moment, then you will not get any effect of magnetic field. Okay. But already we have seen that atom have magnetic moment because of the orbital motion of the electrons, and then get, so we got mu L, corresponding this for this that we have seen mu L. So, here also I will write it, yes. So, we will get mu L. So, where to write? I think I will write, okay. So, we have seen this mu L is L mu B, okay. It is quantized in terms of mu B. So, that we have seen, and that is what we are able to explain the normal Zeeman effect. And now that, so silver atom should have also magnetic moment mu L, and because of applying magnetic field, there will be force on it. Okay. Now, that force, if you apply uniform magnetic field, if you apply, two cases will happen. If you apply uniform magnetic field, so basically you will get torque, not force. So that moment will rotate, okay, due to torque. And if we apply inhomogeneous magnetic field, so we get force. So this system will feel force. Okay, this system will feel force. Okay, so that's the reason that inhomogeneous magnetic field was taken, so that this moment, if silver atom have moment, it will feel the force, not torque. Okay. So, inhomogeneous field, how it was applied? So, basically, you know, in magnet we use pole piece, okay, or permanent magnet one can take. So, it depends on the face of the pole. Okay. If both pole are flat, so it depends on the area of the pole. Okay. If two pole is just flat and parallel, okay, so one will behave as a north pole, another will behave as a south pole. So field goes from north pole to south pole. Okay. So it will, so from same area of the north pole. So here also same area of the south pole. So this force, magnetic force of magnetic lines of force, it will be uniformly distributed. Okay. Now, if this pole is flat and other pole is not flat, it is sharp. Okay. So in that case, what will happen? So these lines of force from this face, from this pole, so it will enter from north pole, and it has to enter to the south pole. So now south pole has small face area, right. So all lines of force will enter into this through this smaller area of the south pole. Okay. So basically all lines of force will condense along this. So now we can see when you are moving from north pole to south pole, you will see this field intensity is increasing. So to produce inhomogeneous magnetic field, so two pole is taken of different face area, pole area. Okay. So that way its inhomogeneous magnetic field is generated. So that way it was taken. So field here, say from south and north pole, and depending on the area of the pole, so the field was also say field was like this. Okay. Field was like, so it was becoming intensity becoming more when it is going towards this direction. So this direction you can take as a z direction. So along the z direction, field is intensity is increasing. So field is inhomogeneous along the z direction. Okay. So along this inhomogeneous direction, so this silver atom, it has magnetic moment. So it will feel force. So it will move towards that towards the direction of the force. Okay. So what after applying inhomogeneous magnetic field, if this silver atom have this magnetic moment, so we will get the shift of this. So we will expect this deposition of the silver at off. Okay. And since if it is space quantization, if space quantization exists, okay, then we should see, depending on this ml value, we should see different discrete deposition of silver on the skin. So, that one should observe. But experimentally what was observed? Experimentally observed that all the time we are getting two spots, one is off from the center, one is up and another is down. Okay. So, whatever we are expecting that due to space quantization we should get splitting of the spot on skin. The splitting of the spot on the skin, it is there. So, they were happy, this Stern-Gerlach was happy that okay, some space quantization exists. So, that is why we are getting, but whatever the splitting quantitatively, it was not matching with the theory, it was not matching with this space quantization. So, that is the problem, that then this experiment, whatever splitting we are getting, it is not because of the space quantization. So, something else. Okay. And then later on in 1925, Uhlenbeck and this Gauss-Smith, they postulate that there is a spin and spin angular momentum, there is a spin angular momentum, it has corresponding magnetic moment also. So, that was considered to explain the fine structure, and but before that, this experiment it was done to see the space quantization. So, but the experiment result is telling no, whatever splitting we are getting, that is not telling about the space quantization. So, what it is telling? So, that was not known in 1927. Okay, in 1927, I forgot the names of the two scientists. They predicted that, they explained that these two one is getting, that is because of spin, and these two spot we are getting for ms equal to plus half and minus half. So, these two splitting, so plus half is going is up and minus half is going down. Okay. So, this is coming from the spinning from the spin magnetic moment, that we will see spin magnetic moment. So, that was the Stern-Gerlach experiment, and they got Nobel Prize. Actually, Stern-Gerlach, they got Nobel Prize because of this simple experiment, which is basically the direct proof of the existence of the spin and spin magnetic moment. Okay. So, I think I will stop here. I will continue next class. Thank you.